This podcast is on the topic of functions and function notations. A relation, and in our particular case we're going to be looking primarily at equations, which have two variables, is a function if a particular choice of a value for the second variable results in only one value for the first variable. We say that the first variable, or what we normally call the dependent variable y, is a function of the second variable, which we call the independent variable x. In other words, independently we pick an x, and then the y that we get depends on x. So x is called the independent variable, y is called the dependent variable. Case in point is example 1. In this equation, if I pick an x, it's going to determine values for y. For example, if I pick x equals 2, then I get that y squared is 3 times 2 minus 2, which is 4. Now, how could y squared be 4? Well, if I square 2, I'll get a 4, so y might be 2. But also, if I square negative 2, I would still get a 4. So y could also be negative 2. So in this particular example, I picked a value for x, the independent variable. It resulted in two values for y, the dependent variable. So we would say that this is not, y is not a function of x, because a choice of x produced more than one value of y. Now contrast that with the second equation, or the equation of example 2. In this case, the y is not squared. If I plug in the x equals 2, I get y equals 3 times 2 minus 2, which is 4. So a choice of a value of x here produces exactly one value of y. So we would say here y is a function of x. Big difference between example 1 and example 2. When y was squared, y was not a function of x. When y was not squared, it is a function of x. Well, what about squaring x? What if we had this example 3 for our problem? Y equals 3x squared plus 2x minus 1. Would y be a function of x? Well, the way to test it again is to pick a variable, pick a number for x. So I'm going to pick x equals 2 again, and see how many numbers we get for y. Y equals 3 times 2 squared plus 2 times 2, if I'm letting x be 2, minus 1. So 3 times 2 squared is 4. 3 times that is 12. Plus 2 times 2. 12 plus 4 is 16. Minus 1 is 15. So when I picked a value of x, I got exactly one value for y. We would say y is a function of x. Now, I want to talk to you a minute about a special notation that we use for functions, which is very powerful. Using this notation, we can give extremely complicated instructions about how to evaluate combinations of functions, but we can give them in a simple way that's easy to work, and I'm going to demonstrate that for you. The symbol f of x, read f of x, may be used in place of y in an equation in which y is a function of x. So up here in example 3, instead of saying y equals 3x squared, etc., I could say f of x equals 3x squared, etc. For example, if y is 2x minus 1, we may write f of x as 2x minus 1 instead. Note that in the function context, f of x does not mean f times x. F of x is the symbol for a single number y. Normally, if you see something like 2 by a parentheses x, it means 2 times x. Not so when you're dealing with functions. This f parentheses x symbol does not mean f times x. It means f of x, and it means the y of a function. Okay, let's take an example of that. Using function notation. Suppose the function y equals 3x minus 4, we call y f of x, so we have the function f of x is 3x minus 4. It says find f of negative 3. How do you evaluate a function or a formula? And we've done that before. There's two methods that we used. One was programming the home screen and the other one was empty holes. When you're doing it by pencil, empty holes is your only choice. So if I want to know f of negative 3, I write this function f right here with empty holes. So I'll write f of empty hole equals 3 empty hole minus 4. And if I want f of negative 3, I'll put negative 3 in the empty hole. So f of negative 3 is 3 times negative 3 minus 4. 3 times negative 3 is negative 9 minus 4, negative 13. Now, we said that f followed by parentheses with a number does not mean multiplication. But if you put a number before f, then it does mean multiplication. It's the number after f that is not multiplied. So in the second example here, we're asking what is 2 times f of negative 3. So that's 2 times some number, and the number that goes here will be f of negative 3. Well, right here, we just found f of negative 3. We said it was negative 13. So this is 2 times negative 13, which is negative 26. Now in the next one, we're asked to evaluate 4 times f of 0 minus 2 times f of negative 1. We can't do that if we don't know what f of 0 and f of negative 1 are. So it's going to be 4 times something minus 2 times something, but we have to figure out what these things are. So let's first go to f of 0. I'm going to write f with empty holes. And if I put zeros in the empty holes, I get f of 0 is negative 4. I write f with empty holes here to get f of negative 1. Negative 1 goes in the empty holes. So I get negative 3 minus 4, which is negative 7. So now I know that f of negative 1 is negative 7. So I put it in the empty hole I left for, see, this whole thing goes in that empty hole, and that's negative 7. And then f of 0 was negative 4, that goes in this empty hole. So now I have 4 times negative 4 minus 2 times negative 7. So that's negative 16 plus 14, because it's negative 2 times negative 7. So that would give me negative 2. So let's go on to our last example. Here the functions get a little bit more complicated. If f of x is x squared minus 2x and g of x, now this is another function, it's still using the same type of notation. You don't have to use f for functions. Normally we use f, g, and h, but really any letter can represent a function name. So here I'm using g for my function name. G of x, remember, is the y, so this means g of x equals this is the same as y equals 3x plus 4. F of x of this is the same as y equals x squared minus 2x. But do you see the problem with the notation of using x and y? Here the y means something completely different than y meant over here. Here y was x squared minus 2x. Here y is 3x. Well, how can we tell the y's apart? Well, we can give them names. We can call this y f of x and this y g of x, and now we can tell them apart. Okay, well, let's do a last example here. We want to know f of negative 3, so we're going to write f, this function, with empty holes. So I'll write f of empty hole equals empty hole squared minus 2 empty hole, and I'll plug negative 3 in the empty holes. So here I get f of negative 3, negative 3 squared, negative 2 times negative 3. Well, negative 3 squared is 9. Negative times negative is positive 6. So I get 15 for f of negative 3. Now I'm asked to find g of 2, so I write g with empty holes. And g is 3x plus 4, so I write 3 empty hole plus 4 and plug 2 in the empty holes. And I get 6 plus 4, which is 10. Now, any time that I'm ever asked for g of 2, as long as this is the definition of g, g of 2 is 10. f of negative 3 is 15. So this problem says, what is 4 times f of negative 3? Well, if f of negative 3 is 15, then that's 4 times 15. And it's going to be 3 times something. 3 times what? So I go over here to get g of 2 is 10. So I plug 10 in here. So I get 60 plus 30 is 90. And I have computed 4 f of negative 3 plus 3 g of 2. And that completes the podcast on function notation.